Today we discuss class P push pull amplifier. So this class P push pull amplifier is widely used in communication systems. So in communication systems, so this push pull amplifier is used both transmitter and receiving end of the communication systems. So here the class P push pull amplifier contain two transistors, two matching transistor or two complementary transistors. So here you can see in the circuit, so here there is a two transistors, and so some of the circuit have one transistor is NPN and another transistor is PNP. The efficiency is about 70%. So this efficiency is more than the class A amplifier. So in class A amplifier, the circuit contain only transistor. The efficiency of this class A amplifier is about 30%. So it is very less efficiency. So efficiency means it is the ratio of output power, so it is AC, and input power, it is DC. So it's called efficiency. So I repeat, efficiency is the ratio of the output power and input power. So output power is in the form of AC power, input power is in the form of DC power. So class P push pull amplifier uses almost all the DC input to AC, means it convert DC power to AC power. So this is the circuit diagram. So this circuit diagram contain two transistors. One is the NPN transistor, another one is the PNP transistor. So here R1, R2, RB1 and RB2 are the biasing resistors. So these biasing resistors provide the suitable biasing to the transistors. So these transistors have the active point is in the cutoff region. So that's why these transistors amplify one of the input cycle, means off. So here the transistor amplify just off wave of the input signal. Okay, so here input signal is provided to both base terminal of the transistors. So here one of the transistor, for example here NPN transistor, so this one is conduct in positive off cycle. So this NPN transistor is conduct, but PNP transistor is in cutoff state, means off in conditions. So that's why here only the positive off cycle of the input is amplified. So that's why it's called push pull amplifier. So here the transistor NPN TR1 is pushes the input, means positive cycle, and transistor TR2 means PNP transistor, it pull the negative off cycle. So it's called the push pull amplifier. Okay, so next, so this is non-transformer push pull amplifier, class P push pull amplifier. So here the circuit doesn't contain transformers, input or output. So here in the case of positive off cycle of the input, the NPN transistor is conduct. So here the current direction is like this. So here the current direction is like this. So in the negative off cycle, NPN transistor means transistor TR1 is in off conditions and TR2 is on condition. So that's why here negative off cycle is amplified by the PNP transistor, means TR2 transistor. So in this condition, the current direction is like this, here to here increases. So overall, the load resistor combines these two waves of waves and produces a single, a combined wave at the output region. So it is class B push pull amplifier. It is non transformer. It is contained not transformers. So next, DC load line. So here I already tell that. So here RB1, RB2 and the R1 and R2, these resistor provide the suitable active point for the transistor. So here the active point of the transistor is lie on the cutoff region. So you can see here the active point is lie in this region, cutoff region. So that's why, so here one of the transistor is in on in the positive off cycle and another transistor is in off, same in the negative off cycle. So transistor TR1 is in off condition and TR2 is in on condition. So because of this reason, so that's why the transistor conduct off cycle of the input. Because of this reason, the transistor completely uses the power of the DC and completely convert the AC power. So next, so here working of a class B push pull amplifier. So these push pull amplifier contain transformers here. So it is a transformer coupled class B push pull amplifier. Okay, so this amplifier is not contain any transformer in the input and output region. So here we discuss working of the class B push pull amplifier and transformer coupled. So here you can see there's a two transistors. So here we use these two transistors, both NPN transistors, and the output is collected at the collector terminal here and here. So both the base terminal contain equal input. So this transformer is center tap transformers. You can see here. So this is the input transformer, this is output transformer. Both the input and output transformer have center tapped transformer. So because of this transformer, the input is equally shared by the transistors TR1 and TR2. So next, here there is a resistors, you can see. So these resistor provides suitable active region for the transistor. So here the class B push pull amplifier, the transistor is the active point, means quiescent point is lie on the cutoff region. So because of cutoff region, so one of the cycle is amplified by the transistors. So in this diagram, so in the positive off cycle, so this transistor TR1 is in on condition, TR2 is off condition. So in this condition, the current flows like this, and in the negative off cycle, so TR2 is in off condition, TR2 is in on condition, TR1 is off condition. So in this condition, the current flows like this. The output transformer combine these two amplified waves. So here TR1 amplifies positive off cycle and TR2 amplifies the negative off cycle. So these transformer combine both positive and negative half cycle and gives the output at the load here. You can see the output waveform of the class B amplifier, so like this. So here you can see the output waveform have some distortion. So you can see here, so this is the output of the class B amplifier. So in this region it is called crossover distortion, because in this region the base emitter region, so it has less voltage, means less than 0.7 voltage. So in that 0.7 voltage, less than because of 0.7 voltage, the transistor is in off condition. So here in this region the transistor in off condition, so that's why there is no output in this region. So when the input voltage, means VBE, is greater than 0.7 voltage, the transistor conducts. So it is called a crossover distortion. So mainly disadvantage of the class B amplifier is the crossover distortion. And the uses of this class B push pull amplifier is, it is very efficient than the class A amplifier, and it uses more DC power to convert the AC power. So it is used very well in the communication system. So this is about the class B push pull amplifier. So thank you.